Alright, today we're going to talk about the volume of spheres, and we're going to spend most of our time on the effects of changing dimensions on volume. So first, volume of a sphere, here is the formula. It's 4/3 times pi times radius cubed. So make sure we're using cubed. One of the most common mistakes I see on these are people squaring instead of cubing. That radius is to the third power. Alright, so find the volume of the sphere below, round to the nearest tenth. Okay, well, I'm just taking this formula. The only variable we have is r, radius. So the radius is always half of the diameter. The diameter is 22, so the radius would be 11. So I'm putting 11 in for the radius. And it tells us to round to the nearest tenth, so I'm just typing this in the calculator. 4/3 times pi times 11 to the third power. Alright, get something like this in the calculator, and it tells us to round to the nearest tenth, so we only want one number after the decimal point. So that 7 is big enough to round up, so that 2 becomes a 3. And volume is always units cubed, so here we have millimeters, so that would be millimeters cubed. That's all you do for volume of a sphere. Alright, so let's talk about what happens when we change the dimensions of a figure. How does that affect its volume? So first, let's start off by just finding the volume of this figure to start with. This is a rectangular prism. Any kind of prism, you just do area of the base times the height. And the base on a rectangular prism is a rectangle. And we find the area of a rectangle by doing length times width. So the area of the base is length times width. And then we multiply the area of the base times the height. So the length and width are 5 and 2. And then the height is 4. So 5 times 2 is 10. 10 times 4 is 40. So this has a volume of 40 feet cubed. Alright, what would happen if we changed the dimensions in this rectangular prism? So the original volume was 40 cubic feet. Let's make the length twice as long. Okay, remember the length was 5, the width was 2, and the height was 4. Alright, let's make the length twice as long. So if I take the original length and double it, that would make it 10. We make the width twice as long, so 2 times 2 is 4. And then we make the height 3 times as long, so 4 times 3 is 12. So if we do that, we're doing length times width times height, just like we did up here. 10 times 4 times 12. And 10 times 4 times 12 is 480 feet cubed. Go ahead and include my units over here. Alright, so let's check and see how that compares to the original volume. If I take the new volume and divide it by the original volume, it will tell me how many times larger it is. And 480 divided by 40 is 12. So we made the volume 12 times larger. Alright, let's try another one. So we start out with our original rectangular prism having a volume of 40. We're going to make the length 3 times as long, so 5 times 3 is 15. Let's make the width no change, so it's going to stay 2. And then twice as long, 4 times 2 is 8. So there's our new length, width, and height. So we got 15 times 2 times 8 is 240 feet cubed. So now let's check and see how many times larger that is. So we take our new volume, we divide by the original volume, and it shows us that we got a volume that's 6 times larger than the original. So let's see if we can figure out what kind of pattern is happening here. It says, what conjecture can you make regarding the effect of changing dimensions on volume? Well, we doubled this, and tripled this. 2, 2, and 3. 2 times 2 is 4, times 3 is 12. 2 times 2 times 3 is 12. Right here, we multiplied the length by 3. If there's no change to the width, that means we multiplied by 1. Some people want to think no change 0, but if we multiplied it by 0, it would be 0, not 2. We multiplied 2 times 1 to not change it at all. And then twice as long multiplied by 2. So we multiplied by 3, we multiplied by 1, we multiplied by 2. 3 times 1 is 3, 3 times 2 is 6. If you take the change in each of the 3 dimensions and multiply those together, it will give you the change in the volume. So let's write this out. So multiply the change in each of the 3 dimensions to find the change in the volume. So let's try an example using this concept. Now that we have this concept, suppose the volume of a right triangular prism is 360 cubic units. What would be its new volume if one of its dimensions was twice as long, the second dimension was 3 times as long, and the third dimension was half as long? With the way this problem is worded, it really doesn't matter what type of figure we have here. They told us that one of the dimensions is multiplied by 2, the other dimension is multiplied times 3, and the third dimension is half as long. We find out what the change in each dimension is, what we're multiplying each dimension by, and we multiply those all together to find out what the volume is being multiplied by. So 2 times 3 is 6. 6 times a half is 3. So it should make the volume 3 times larger. So I'm just going to take the original volume and multiply it by 3. And that will give me the volume of the new figure. Let's try the next one. It says, find the volume of the cone below, leave answers in terms of pi. So, for the volume of any cone, it's 1/3 times the area of the base times the height. And in a circle, the base, or excuse me, in a cone, the base is a circle. So when we're doing area of the base, it's pi r squared. That's the formula for area of any circle. So the radius is 3. So 3 squared is 9. Remember, we're leaving it in terms of pi. So that means we're not actually putting pi in the calculator. We're going to just leave pi sitting right next to that number. Alright, so we know the area of the base is 9 pi. And then the height is 2. So again, if we're leaving it in terms of pi, I'm multiplying all those numbers, but I'm not putting pi in the calculator. I'm not actually multiplying by pi yet. I'm leaving pi right next to the number to show that they need to be multiplied, but I'm not actually doing it. 1/3 times 9 is 3. 3 times 2 is 6. So we end up with 6 pi. This cone has a volume of 6 pi. And volume is always units cubed. Alright, so let's come down here. What would happen if we change the dimensions in this cone? Alright, the radius is originally 3, and the height is originally 2. So let's see what changes they want us to make, and we'll see what happens. Alright, we want the radius to be twice as long, so 3 times 2 is 6. We want to change the height. So we want to make it 3 times as long, so 3 times 2 is 6. So I now have a radius of 6 and a height of 6. Let's find the new volume. So if I'm doing that right here, just to save space, I'm going to go ahead and put that pi r squared in place of big B. We know for a cone the area of the base is found by doing pi r squared. So there's my formula. So the radius is 6 and the height is 6. So we put all that in there. Now remember, we're doing it in terms of pi, so I'm not putting pi in the calculator. So we got 1/3 times 6 squared times 6. And that gives me 72. And don't forget to put the pi right next to it. So 72 pi units cubed. So now, if I take my new volume and divide it by the original volume, I'll find out how many times larger it is. Now that pi kind of takes care of itself for you. You got pi being divided by pi, so those will cancel, and I can really just focus on 72 divided by 6. So 72 divided by 6 is 12. So we made the volume 12 times larger. Alright, let's try the next row. Okay, we're going to make the radius 4 times larger, so 3 times 4 is 12. And we're going to make the height half as long, so half of 2 is 1. So let's do another volume formula over here with our radius of 12 and our height of 1. So we got a radius of 12 and a height of 1. So I'm typing in the calculator. Remember, do not include pi in the calculator because we're keeping it in terms of pi. And you should get 48, and then we remember to put the pi right next to it. So 48 pi units cubed. So take the new volume, divide by the original volume, and we'll find out how many times larger it is. Again, remember, pi divided by pi, those cancel. 48 divided by 6 is 8. So we made the volume 8 times larger. Alright, if you're trying to think about how we came up with the pattern last time, you might think, alright, well, we multiplied this by 2, multiplied this by 3, 2 times 3 is 6, but it ended up being 12 times larger. Remember that volume is 3 dimensions. And yet, we only have 2 different numbers here. But there's 3 dimensions. One of these is accounting for 2 of the dimensional changes. If you think about a circle, the radius of that circle is the same no matter where you draw it. So when you change that radius, it not only changes the length, but also the width of that base. It changes 2 dimensions. Because the radius changes 2 dimensions, that's why it is squared in the formula. It's being squared, multiplied times itself, because it is responsible by itself for 2 of the 3 dimensions. So we need to remember that the radius is accounting for 2 of the 3 dimensions. So when we multiply our 3 numbers, it's 2 times 2 times 3, or 2 squared times 3. So 2 times 2 is 4, 4 times 3 is 12. So same thing here. This radius, this change in the radius, that's change in 2 different dimensions. So I'm using this 4 times bigger. I'm using that twice. 4 times 4 is 16. 16 times a half is 8. So just remember that that radius is being squared. It counts for 2 dimensions. So you have to use this number twice. Square it. Alright, so let's try this down here. Suppose the volume of a cylinder is 240 cubic units. What would be its new volume if the radius was doubled and its height is quadrupled? Alright, the radius is doubled. So that means it's multiplied by 2. Now remember, the radius accounts for 2 of the 3-dimensional changes. So I'm using that 2 for 2 of the 3 dimensions. And the height is quadrupled, which means it's multiplied by 4. So 1 dimension is being multiplied by 4, and 2 of the dimensions are being multiplied by 2. So I have what each of the 3 dimensions is being multiplied by. And we multiply. 2 times 2 is 4. 4 times 4 is 16. So the volume is going to be 16 times larger. So then I just take the original volume of 240 and multiply it by 16. And I know that the new volume is going to be 3,840 cubic units. Alright, let's go to the last page. Find the volume of the sphere below. So remember, the formula for volume of a sphere is 4/3 pi r cubed. And the radius here is 6, so we just plug that 6 in for the radius. And I'm typing this in the calculator. It says leave answers in terms of pi, so remember not to put pi in the calculator. And you should get 288 pi. And this was in inches. Volume is always units cubed, so it'll be inches cubed. Alright, so our original volume is 288 pi inches cubed. We're going to find out what happens when we change the dimensions. Should be hopefully getting a good idea how this works. What would happen if we change the dimensions in the sphere? Well, again, that formula is real simple. There's only one thing to plug in, and that's the radius. Notice that the radius is cubed. It's because the radius is in charge of all three dimensions. This radius affects the length, the width, and the height of the entire sphere. It affects all three dimensions. So, if the original radius is 6, we'll make it twice as long. That would be 12. 6 times 2 is 12. Let's do the formula using 12 now. So we got 4/3 pi times 12 cubed. 4/3 times 12 cubed. That would come out to 2,304 pi inches cubed for the new volume. Now, if I take the new volume and divide by the original volume, again, the pi's are going to cancel. 2,304 divided by 288, you should get 8. So that means that the volume is 8 times bigger. Well, remember that the radius affects all three dimensions. So each of the three dimensions is multiplied by 2. So 2 times 2 times 2 is 8. It's going to make the volume 8 times larger. Or you can just say 2 cubed is 8. So same concept down here. Let's make the radius 4 times larger. So 6 times 4 is 24. So now let's do this 24 as the radius. So 4/3 times 24 cubed. And that's going to get you a large number. 18,432 pi inches cubed. So then when we take our new volume and divide it by our original volume, again the pi's cancel, but you should get a volume that is 64 times larger. And again, the radius affects all three dimensions. 4 times 4 times 4 is 64, or 4 cubed is 64. Alright, this was a situation where we had similar figures, the sphere. It says if all dimensions of a figure are multiplied by the same number, the sides are changed proportionally, then the new figure will be similar to the original figure. Remember that corresponding sides of similar figures are proportional. So what conjecture can you make regarding the volumes of similar figures? We can say that the scale factor can be cubed, or multiplied it times itself 3 times to find the change in the volume. Now I used the vocabulary word scale factor here. Remember, with similar figures, the scale factor is what you multiply the sides by. So in this example, when we made the radius twice as long, the scale factor was 2. So 2 cubed is 8. The volume's 8 times larger. Here we multiplied all the sides by 4. So in this case, the scale factor was 4. 4 cubed is 64. So that's how many times larger the volume would be. So let's look at example 7. Suppose the volume of a triangular prism is 56 cubic units. What is the volume of a similar figure with sides 3 times as long? So I know that they're going to be similar figures. That means that all the dimensions, all 3 of them, are multiplied by the same number. That's the only way that they are changed proportionally. So if all the sides are multiplied by 3, you can think of it the same way we've been doing the others. First dimension is multiplied by 3, second dimension is multiplied by 3, third dimension is multiplied by 3. So the volume is going to be 27 times larger. This is kind of following the same pattern we did on the other problems. If you're focusing on what we just wrote down, you would say, I'm just going to take the scale factor and cube it. Either one, you're doing the exact same thing. Whichever way you like to think through it. We should realize that the volume is going to be 27 times larger. So I take the original volume of 56. We multiply it by 27, and that tells me that the new volume will be 1,512 units cubed.